This video is on the perpendicular distance from a point to a line. This is also called the shortest distance, as the perpendicular line or the perpendicular distance is also the shortest distance. If it wasn't perpendicular, the distance would be longer. So either perpendicular distance or shortest distance. So when we have the line, the equation of the line, it has to be in the form ax plus by plus c equals 0. If it's not in that form, you have to bring it into that form. And we have a point x1, y1, and then here we have the formula. So the modulus of ax1 plus by1 plus c over the root of a square plus b square. So the two lines down here, remember it means whatever's inside, it has to be positive. So if we end up with a negative number, the modulus will turn it positive. Okay, so let's look at an example of this. So again, it is the same as with all the other segments in this chapter. We start by labeling. So 2 and minus 4 is the point. So find the perpendicular distance from 2 minus 4 to 3x minus 4y minus 17 equals 0. So we label the 2 is our x1, the y1 is minus 4. And then we have the 3 is A, the minus 4 is B, minus 17 is C. So we now put that together. So D equals the modulus, and then we have 3, x1 is 2, plus B is minus 4, y1 is minus 4 as well, and we go plus C minus 17, and the modulus of that, i.e. the 2 bars, over the root. And now we have A is 3. Get into the habit of putting that into brackets with the square outside of the bracket. Plus, and B is minus 4. Especially here with negative numbers, it is very important that we use brackets and that the square goes outside of the bracket. Okay, so we calculate this now. So D equals 3 times 2 is 6. Minus 4 times minus 4 is 16. Plus, minus 17. And that over the root of 9 plus 16. Okay, so on the top, 6 plus 16 is 22. Minus 17 is 5. And this would be the root 25. So we can take away the bars, but it's already positive, so we don't change anything. So 5. The root of 25 is 5, so 5 over 5 is 1. So 1 is the distance, so this bit would be 1. This is the distance between the point and the line. Okay, so we're going to look at a different type of question now. Okay, so the idea here is that if we have two lines, we can put the right. Let's first see. So we have two. We have to show that the point 2.2 is on this line. Okay, so what we do, we just label again x, and this is the y, and then we just put it in. So 3 times 2 minus 1, so it's nothing there, it is 1, times 2 minus 4 equals 0. And we have to show that this is true. Yeah, so 3 times 2 is 6, minus 1 times 2 is 2, minus 4 equals 0, and 6 minus 2 minus 4 is 0. 0 equals 0, so that is true. So that means that the point, so this would be 3x minus y minus 4 equals 0, that the point 2.2 here, 2.2 is on this line. Okay, so let's look at the two lines now. So if we have 3, let me go a bit further down. Okay, so 3x minus y minus 4 equals 0, and on the other hand we have 6x minus 2y plus 7 equals 0. So if we look at this now and calculate the slope of each of one, we don't have to, but I just want to show you something. Okay, so remember this was A and B and C, A, B and C, and if we go minus A over B, we get the slope M. Okay, for the left we have minus A is 3, B is minus 1. So the minus and the minus, they cancel each other, so we end up with 3. And on the other one, again, we have minus 6 over minus 2. The minus cancels each other, and 6 divided by 2 is 3. So as you can see, they have the same slope, 3 and 3, which means they are parallel. Yeah, so I can draw here a parallel line. And that would be now 6x minus 2y plus 7 equals 0. This would be parallel to the other line. So they want us to calculate the distance. Oh, here it says already they're parallel. Yeah, so they want us to find the shortest distance between these two parallel lines. So that means that the distance is the same here, the same here, and the same here, and also the same on this point. So what we can use here is the distance between this point 2 and the line, and that would give us the distance between the two lines altogether. Yeah, because that distance is the same everywhere. Yeah, so all we need to do is find a point on one of the lines and then calculate the distance to the other line, and that gives us then the distance between two parallel lines. Okay, so we have our point 2, and we have our line 6x minus 2y plus 7 equals 0. So let's write down the formula again. D equals the modulus of ax1 plus by1 plus c over the root of a square plus b square. So let's label everything. So this is our A, B, and C, and this is our x1, y1, and then we just put it together. Okay, so D equals the modulus of A is 6, x1 is 2, plus B is minus 2, times y1 is 2, and then we have plus 7 for C. Okay, we take the modulus of that and we put it over the root of 6a square is 6 square. Remember, get used to putting that into brackets, and b minus 2 squared. Okay, so let's calculate this. Okay, so we have 6 times 2 is 12 minus 4 plus 7. So that would be 15. The modulus of 15, yeah, but that is just 15 over the root of 6 squared 36 plus 4. And so that would give us root 40. Okay, so the modulus of 15 is just 15. And root 40, we can leave it as root 40, or we can also write 2 root 10. Or if you put this in your calculator, it would give you 3 root 10 over 4. But if you leave it as 15 over root 40 or 15 over 2 root 10, that's fine as well. So that is about 2.37 as a decimal. Okay, yeah. So we have now found that the distance between the point 2, 2 is 2.37, and that also means this distance is 2.37, and this distance is also 2.37, as the lines are parallel. So the distance from the point to the line is also the distance between 2 parallel lines.